The nuclear magnetic resonance spectroscopy (NMR) is a technique used mainly in the field of chemistry and biochemistry for the structural determination of chemical compounds. There are atomic nuclei that spin around their own axis, generating a magnetic field, and this can be analyzed by NMR. The most commonly analyzed elements are hydrogen, carbon, nitrogen, fluorine, and phosphorus, and the most used in organic chemistry are hydrogen-1 and carbon-13. In this technique, the atomic nuclei are subjected to an external magnetic field of the order 0.1 joules per mole and 10 to 600 MHz, which produces energy changes in the orientation of spinning atomic nuclei in a magnetic field. Here, it is represented how the nucleus by itself carries a charge that produces a magnetic or dipole moment, and how its orientation changes when it is subjected to an external magnetic field B0. To carry out this type of analysis efficiently, it is required from 50 nanomolar to 50 micromolar of a liquid or solid sample, preferably pure. These mixtures are more difficult to handle, and an equipment consisting of a conducting magnet and its controller, which generates a magnetic field where the sample is placed, a radiofrequency wave transmitter used to make the NMR measurements, and a detector that is connected to a computer as well as the magnet controller for the control and data processing. The intensity, position, and shape of the signals in the spectrum of a given nucleus are closely related to its molecular structure. A detailed analysis of the spectrum provides valuable information about the structure of the compound that originates it. An NMR spectrum contains information about the chemical shift, that is, the spectra of a compound can show several absorption bands corresponding to a particular nucleus. The splitting, it means the division of a given signal into many peaks as a result of interaction between different nuclei. And the integrated area of an absorption peak is directly proportional to the number of nuclei responsible for the signal. This provides a quantitative analysis method. NMR spectrum can be applied to study the structure and dynamics of organic and organometallic compounds and biomolecules. Some examples are its use in medicine for the monitoring of metabolic pathways and their regulations, and in other areas for the analysis of food and beverage, among others. In my opinion, the class of instrumental analysis in biotechnology was very useful to know the most used techniques in this field, and based on that, to have the knowledge to be able to decide those that I will apply in the development of my thesis project, in which I will have to analyze bioactive compounds from different parts of discarded jackfruit.